Hello and welcome to the Fully Charged Plus podcast. I'm really enjoying doing these shows, just meeting such incredible people and talking to them from all over the world. Today's guest on the show is literally no exception to that rule because he's amazing. It's Professor Jack Macaulay, who I'm going to have to just check that I get this right. It's really important. He is a professor of engineering and teaches environmental vehicle engineering class at UC Berkeley in just outside San Francisco, or in San Francisco. I've been past it. I know where it is. So that's what he does now, and he's talking. And we have an amazing conversation about batteries and electric motors and electric vehicles and the history of electric vehicles and where the power comes from and how that it's used and how efficient they are. Blah blah blah. All those things. Really, that's what we're talking about. But I just want to quickly tell you a bit of Jack's background because it is extraordinary. So you may have in your time plugged in a USB cable. We've all done it. And USB stands for Universal Serial Bus. We've all done that. Well, there was numerous people that got together to invent the Universal Serial Bus connector for computers. And one of them was Jack. He also created the original scrolling feature for a computer mouse. So you move the mouse. Yes, that moves it up and down. That moves the cursor around the screen. But what about the actual when you're scrolling through a document? Jack was involved in that. Some of you may, in your youth, or maybe you still do, have played Guitar Hero. We do briefly talk about that. Jack was involved in creating that. Some of you may have put on VR headsets so that you can live in an alternate universe. Many of you will have heard of Oculus Rift. Well, Jack Macaulay was one of the founders of Oculus VR and manufactured the Oculus Rift. And Oculus was later acquired by Facebook, which was, he's got this amazing history. But now he's working on, hardware. He's a car nut, so he's working on lots of electric cars, and we'll hear all about it. It's wonderful. But before we start that, just want to have a quick word from our really wonderful sponsor, who makes the Fully Charged Plus podcast a possibility. And a continuation. We've done over 100 episodes, and a lot of that is down to our fabulous sponsors. Let's hear from them. My Energy is putting the I back into British innovation. My Energy is putting the I back into inventing the future. My Energy is putting the I back into inspiring a nation. Recharging the world with green, smart energy. Charge your EV with your PV and more. Visit myenergy.com and help to spark the green revolution. My Energy, driving the charge to a greener future. Well, that's enough waffle at the start of the show. Please do welcome to the Fully Charged Plus podcast, Professor Jack Macaulay from California, USA. So, Jack, thank you so much for joining us today. I think we should say that we've had a couple of little technical hiccups, but we've got there in the end, which is really good. I just want to it's so wonderful to talk to you. It's a real thrill and a pleasure to meet you like this. But I just want to quickly list for our listeners some of the amazing things you've done in the past before you started looking at electric vehicles and batteries. But I've got to say, sure. I mean, I'm not very good at computer games, but I have played Guitar Hero, and I really love doing it. And I'm not a musician, so that was one of yours. That blew me away when I found that out. I was really impressed. So I don't even know, when was that? When was Guitar Hero launched?
Well, the brief backstory and history of Guitar Hero is that I was contacted in 2005 by one of the fellows that I was working with from Take-Two, who stated that he knew these two guys who were in a startup company that wanted to build a guitar game. And I said, okay, let me see it. So at CES in 2005, they had a demo written by a company in Boston, a video game studio. These two guys had a video game rental business. So this is sort of their first foray into a video game. I think long story short, I went in there and saw it, and I thought it was weird, and I didn't understand why. I come from kind of, first person shooters and cockpit games, and why anyone would want to pretend to play the guitar. And but I did it anyways because I was trying to help the guys out. I liked them, and the guy I was working with said you should help them, and so I did. But little did I know how popular it would be. I saw it on TV and cultural things in the United States and other parts of the world. And it was phenomenally successful. And the interesting part about that is we couldn't find a publisher willing to acquire the company and take on the project. We just couldn't find them. They didn't know how to deal with it. Just like me, I'm like a traditional gaming guy. And so that's the story of Guitar Hero, and it just phenomenal success. It's funny, you take other forms of compensation when you go to work for a startup. They don't have a lot of cash. You can't take a big salary. So I took some stock options and some other stuff, and it worked out phenomenally well for me. Guitar Hero became Oculus because of my work on Guitar Hero and video games in general. But mostly the Guitar Hero is why I got hired by Facebook, by Oculus, purchased by Facebook. So it worked out very well for me, although it's a very tough business to be in, and you can imagine it's entertainment. It's just really hard. It's worse than automotive, believe it or not.
That's interesting.
High risk, high reward, and high potential for failure. So
I mean, that's the thing. So if you think of that, I know there are thousands of potential huge global hit games that neither of us have ever heard of because they didn't become global hits. I mean, there's been I know some people who've worked on, I've done voiceovers. This game's going to be huge. It's going to be bigger than Grand Theft Auto. I've never heard of it again, so they don't always work. I'm absolutely aware of that. Yeah. But then I was intrigued by the potential crossover of the kind of the software and the hardware behind something like Oculus Rift and or autonomous driving. I mean, is there a direct link between those two, or am I jumping to too many conclusions?
Well, I would say that there is potential for collusion in technologies for autonomous driving. And let me explain that briefly. There is a technology called SLAM, and the Microsoft HoloLens was the primary exploiter of this. And what it does, it's a pair of cameras, stereo cameras, and from those stereo cameras, it can figure out the dimensions of a particular space. And these dimensions can be stored in the cloud and then retrieved by future users of that space. So, for instance, you walk into, let's say, a room at a library, and there are books on the shelves. You're recording that room in 3D with depth and all the artifacts for use by the next person that comes along. HoloLens used SLAM technology to do its positional tracking. This is not what we did at Oculus at all. Ours was a much simpler thing. We were a seated experience. So it wasn't that type of room experience VR that they had. But SLAM, which has been around for a while, it's called simultaneous localization and mapping. How that plays into autonomous vehicles is in the following way. Let's say you're in the future car and you're driving down the highway, and the driver needs to take a break. The objects on the highway, the artifacts, the permanent artifacts, the road signs, the exit ramps, because those were mapped in SLAM by prior drivers.
Right.
So this is the crossover. I wouldn't say that I could see people wearing 3D headsets on driving around in cars, but certainly the mapping, the localization and mapping component of VR and XR, if you will, is a technology which is a direct application to autonomous vehicles. It's the way, if I were to do an autonomous vehicle, that's what I would do.
Right.
I would take information that's available, much like the cars that go around and do Google Maps and Street View and stuff like that. It's kind of like that a little bit. Yeah. Every car has a Street View. Yeah. And it's updated as often as a car drives down that street or on that path.
Right.
So this is the key, I think, to autonomous vehicles. Really, is it's actually the simplest thing to do.
Yeah.
And Furthermore, it can actually map, let's say a broken down vehicle somewhere, things of that nature, an obstruction of some sort, a traffic situation. It can also map those artifacts too. So
Yeah.
it requires, what does it require? It requires nonstop connection to the cloud over a 5G network, a cellular network somewhere, which we really don't have that right now, that
Yeah.
kind of bandwidth. So it requires that. But we're getting there. How it was just a short time ago, it was a struggle to watch a full high res movie on your phone when you were walking around. It's not such a struggle
Yeah.
anymore, is it?
No, it's extraordinary, isn't it?
So
Yeah.
yeah, so it's just it's happening. It just doesn't happen at the pace that we human beings imagine things to happen,
Yes.
or
Yeah.
Hollywood like results don't really occur.
No.
So anyway, to
But
make a long story
then,
short,
so now, I
that's the
mean,
crossover.
you're certainly now, talking about the future of electric vehicles. I mean, I know Roger Atkins, who I know you spoke at. Roger and I go back a long way. We've known each other a long time, but he was
Great.
blown away by what you're doing. But so, can you give us your take on the future of electric cars and where you see that going? And I mean, do you think globally have we? I'll just say what I feel. I feel that we have passed a form of a tipping point in terms of public acceptance and acknowledgement of this new technology. It's not that new, but I do feel a real shift in attitudes, not necessarily in the technology, but in the attitudes towards them. I mean, I don't know if you agree with that.
Yeah, I think I was a naysayer of Elon Musk and Henrik Fisker 10 years ago. I thought they were from another planet.
Yeah.
How wrong I was. I think what's happened is remarkable. It has consequences.
Yeah.
In California, we cannot support everyone owning an electric vehicle. The infrastructure on the grid does not exist right now to do that. Uh, Albeit if everyone had solar panels on their roof, which a lot of people do right now, you could actually charge a vehicle on solar panels locally. But we just don't have the infrastructure to do that right now. And it's a ways out. And knowing how things go around here in California, it's a long, long ways out. Things happen very, very slowly here. So we're supposed to be, sort of the hipster, cutting edge state, but in reality, the bureaucracy here in actually accomplishing the things that we dream of doing in California don't happen that way. So,
Yeah.
but it's a real, the tipping point has occurred. The real breakthrough in electric vehicles occurred in the 90s with lithium ion batteries.
Yeah.
That technology was the first time you could get in a reasonably small package a fully rechargeable with many cycles on it. You could actually discharge it many times. Battery that was not lead acid, not a conventional storage battery. The nice thing about lithium-ion batteries is this. This is the best part. Sure, they have a lot of energy capacity. They have a lot of, if I may use the word, joules in them of energy available. It's like, think of it as sugar cubes. They've got tons of sugar cubes in them, very highly dense. But the best part is the flat discharge curve. In other words, they hold their output at a fairly consistent level for a long time. It's the first battery that can actually do that.
Right.
Lithium, a rare earth metal battery. And what's the beauty of this? It's guaranteed power availability. In other words, you always have power available no matter the state of the battery. And you may have noticed this if you drive an electric vehicle. It really doesn't go slower as the battery is getting discharged.
No.
And that really has to do with the battery technology. So this is the key part of in class. I teach electric vehicle stuff at UC Berkeley. I say, what's the most profound invention of the 20th century? I say this to people. Some people say the microprocessor. Some people say one thing, and I say, no, I think it might be a battery. I think it might be a lithium-ion battery. It profoundly changes humanity, the way we go about doing our lives and our business, the effects on everybody. If there was not a lithium-ion battery, a rare earth battery, you would not have a mobile phone that has the power of a PlayStation 3 in your hand. Wouldn't exist without a lithium-ion battery.
Yeah.
You wouldn't have the connectivity. There wouldn't be the pressure on the internet for high bandwidth. that there is now, because they're going to be sitting at a laptop somewhere. So it is a profound invention. It has going to influence transportation profoundly. So I think you're right, Robert, that there's we've reached a tipping point. Probably reached it 20 years ago, but I think profoundly the lithium-ion battery, the rare earth batteries, and the future of batteries. We talk a little bit about later in this podcast.
Yeah.
What is happening with batteries, solid-state batteries? The pressure is on. Without the demand for higher capacity and lower mass volume, higher density batteries, there wouldn't be the thrust into solid state batteries and higher capacity batteries. And there's a big push. A large part of the weight of a vehicle like the Tesla Model S is the battery. If you could reduce the battery size by half, reduce the weight by half, and have the same range, you could actually, the energy, let me put it this way. If the battery was half the size it was now, that you would be able to go even further, because you have reduced the total mass of the car, the total weight of the car is less. You'd be able to go further because you're not using as much energy to push it around. So there's a big push for that right now. And also domestic manufacturing. We need to be able to make these batteries in places in Europe, let's say, perfectly capable of manufacturing things like that there, and the United States. And we also need a very, secure supply of rare earth ore, which we really don't have in the U.S. right now. We have it, but it's kind of hard to get to. So,
right.
The long and short of it, tipping point has been reached, and the motivator behind this tipping point was the availability of the rare earth metal batteries that have very high energy densities and very flat discharge curves. So
right, because I think that's it. I mean, it's so important what you're saying in the fact that the general public, and I mean all the people I know, including myself, who drive electric cars regularly, may not have put those essential things together. The fact that as a battery depletes, so you're driving along and it says you've got 15% of the capacity remaining, it doesn't go slower. I mean, I know that from experience, but I've never actually put it into words like that. And it's an important thing to explain to people who've never driven them, because that might be an assumption that it's nearly run out. So there's, I mean, is it the case, say, if you had a lead acid battery pack, forget the weight and the size for a moment, as it depletes, does that lose the ability to send to power a motor?
And not only is that true, it is the reason that electric vehicles were not prominent, I would say. A lead acid battery is a very, very, 100 years, a very inexpensive, albeit kind of a dirty technology with lead, which is causes health problems, and sulfuric acid, which is also kind of nasty and dangerous stuff. The reason they're not prominent is just the chemistry of that particular battery, the discharge curve. As let's say the battery's 80% discharged, it's not at, let's say, 13 Q or 13 volts or whatever you want to say. It's now at 8 volts, and it can't put out the kind of power that you demand, and it's noticeable when as you start to drive around, you say it's losing power. I have to put my foot down, and pretty soon you can't go 60 miles an hour. You can go 40 miles an hour, something like that. So that is the primary reason. The significance of the lithium-ion battery is just it's being felt by society right now. What a profound thing that is. And the emphasis on making them more dense, reducing the size for the equivalent amount of joules or energy coming out of it is really what the thrust is. I have two EVs. I have an R&D facility where I've built two others, which are experimental EVs to play around with the architecture a little bit. And I can explain. One of them is a pure race thing. It's just, it's unbelievably quick and scary fast. And the other one is more is a vehicle that the battery's never been recharged.
Wow.
And it has a small petrol engine, a gasoline engine on it that can't power the vehicle. The job of that small gasoline engine, and it runs at maximum efficiency, which is about 40%. It's pretty good. So 40% of the sugar cubes that go into the into this little gas engine actually end up as joules or power going into the battery to
Right.
charge the battery. It basically parks and charges the battery and tops the battery off. So whenever you get on it, the battery's full.
Right.
Now, if you run out of gas, you still have a full battery. You can drive around, but if you run out of gas and drive the battery down to nothing, then you have
eventually
to
you stop.
You stop, yeah.
Yeah.
It still has that problem.
Yeah.
And the beauty of this thing is that I changed the layout of the battery. So I have a propulsion battery, which is used to propel the vehicle, and I have a braking battery that is used to brake the vehicle. And the braking battery, it absorbs all the inertia of the vehicle, kinetic energy of the vehicle,
Right.
and puts it into a braking battery. And when you stop, it trickle charges back into the propulsion battery to top the propulsion battery off.
Yeah.
Instead of using one battery. What's the beauty of this? The beauty of this is because I've divided them into two batteries. If I need a hard brake on the thing, I can use both batteries to hard brake. So this vehicle has no mechanical brakes on it. It does not have conventional brakes. It's all electronic braking.
Wow.
With two motors.
And you can do an emergency stop from effectively regenerative braking, or
it's
hard
pretty
stop.
hard. It's about what you would experience with ABS brakings, where it won't lock the tires up, but it does stop the vehicle.
Wow.
The Tesla, the Model S, and the Model 3 to a certain extent, they have mechanical brakes on them. They're the mechanical brakes. The reason that they have mechanical brakes is it's a great big heavy vehicle.
Yeah.
It also very fast. It goes 100 miles an hour, and there's just not enough battery current, power handling capacity to take all that energy out of the car. So they have to have mechanical brakes on them. This vehicle, because it's light, it's a single occupant vehicle, little commuter vehicle. That's the thinking.
Yeah.
Is that it doesn't need mechanical brakes at all.
Wow.
It can just sit there and hold. It can park it on a hill. It'll sit there and hold on the hill.
Wow.
So this is the thinking. It's just an experiment. I don't know where it's going, but I think, and I presented it to the class at UC Berkeley, talked about it, and also tried to get interns to help me finish it up. But it is great. It's very simple. And as Henrik Fisker said to me, when I was endeavoring into going into this field and exploring electric vehicles, he goes, an electric vehicle lasts forever. There's not much to wear out.
Yeah.
The powertrain, which is the connection between the electric motor and the wheels, is almost a direct drive.
Yeah.
Almost goes directly to the wheels. There's no much transmissions or intervening hardware in there. And that just doesn't wear out. Some of the motors, like the motor in the Model S, which is called an induction motor, those things sit in factory chimneys. It's essentially the same thing as Tesla, came up with in the 19th century. Those things sit up in smokestacks in factories and run a fan 24/7 for 50 years and never wear out.
Wow.
They just don't wear out.
And that's unbelievable, isn't it? If you just think any machine that can run at that pace for that long is remarkable.
Yeah, it can. Yeah, wow. Without wearing out the batteries. The bearings go out, they can, but generally they don't.
Yeah.
Their axial loading on it is, they're just axial loads. They're just the kind of loading is on a fan is very, very balanced loading. So they last forever. So the potential is the powertrain on EV could last for 30 years.
Yeah.
But here's the thing: is the vehicle goes out of style. The styling. Look at the cars from even the 90s. They look kind of like rounded off, looking and weird looking.
Yes.
So the style. But what if you could just rebody it? Like you take it into a rebody shop. They sell rebody kits from popular cars. They just they fix all the bushings and suspension stuff, give you new brakes or whatever you need on it, and they just drop another body on it. It's not sold as a new car. It's sold as a reconditioned or something like that.
Yeah, I like the term rebodied.
Yeah, rebodied.
Have you seen my rebodied Jaguar? It sounds cool.
Right. I think Jaguar would want to sell you a new car, but
they would.
So, but this is the idea that Fisker had, and I never thought about that. I always assumed like an internal combustion engine based vehicle, 150,000, 200,000 miles. They're getting tired.
Yeah.
Pretty soon it's at the scrapyard. And all that energy went into that produce, all the carbon emissions, what have you, that went into produce that car are all gone forever. They're still up in the atmosphere. If you could actually recycle the car, there would be a market for that. I don't want to pay a lot for an EV. I want to pay half of what I pay for a Tesla Model Y or whatever. I can get a reconditioned version of this for that, and it does everything I need it to do, and it costs a lot less.
Yeah.
And so you can even export them to other poor countries, let's say, who don't have domestic EV production. You could just sell the rebodied stuff there. So this is his idea. I thought it was a great idea.
Yeah. I mean, it is. I think what's certainly one of the things that got me really interested in the whole topic was it kind of released an enormous amount of creative energy around something that was had become very mundane and we're all used to, a car, and it was so much more exciting than here's the next version of let's stick with Jaguar because they're just up the road from me. Here's the next exciting version of the Jaguar, which looked exactly like the last one, but the front was slightly different and they did a different light at the back. Who cares? And now, although they're going through the traumas that many big car companies are going through, they're building electric cars. They are totally different, and they're as thrown by the fact that they've made an electric car as anyone. It's really interesting talking to the engineers at Jaguar Land Rover because they're going, this electric car stuff is amazing. You go, well, you make them, you should, but there's the engineers I'm talking about, not necessarily the PR people or the management, but the engineers are just completely blown away by it, because it opens up so many other possibilities in terms of engineering.
The electric vehicle is the first vehicle which is primarily driven by software. It's a software-based platform.
Yeah.
If you look at the Tesla Model S, the Tesla in general, they're heavily software-based.
Yeah.
And I always tell people that you're really driving around a computer program.
Yeah.
Because the control electronics, the control algorithms for monitoring the motor function and power output, motor speed, that the motor speed is being translated, the car speed is being translated from your foot position into a computer that says, he's doing this, going up a hill, this much power is required. That's all done in software.
With software, it's amazing, isn't it?
Probably written in C code. Yeah. Some engineer at Jaguar sitting in a cubicle writing your, there are. And the whole entertainment system on the Tesla, the center console, it's kind of, to me, honestly, I have one. I don't like it that much. It drives me crazy because I want a traditional push button start.
Yeah.
When you get in, that's the first thing I look for. Where's the button to start?
Where's the button? Yeah.
Yeah. And then you go to shift it, and you put it in, and you think you're going to reverse. I'm moving the arm around. I'm going, where's reverse? But that's just me. I mean, a lot of people think it's great. And online updates, they update the firmware
extraordinary.
at night. Yeah. And that's just what it's becoming. It's a great business platform if you could somehow talk Tesla into adding apps to it. I don't know if they do that or not, but there's a great market for that. You could have I suppose that Elon Musk wants to own that platform, but you could have your own apps, Tesla apps, people could download and use in the car. Nothing comes to mind. I guess a better, if I were Google, I'd be looking at it going, we should write an app, a maps app for that or something. But it is cool. It's very complicated. Tesla's so far ahead of everyone. Jaguar, you have the e-Pace, and I don't know what their vehicle programs are.
No.
By the way, I love British cars. I have three of them.
Right.
I've got a Bentley. I've got a Lola T70 Mark IIIB, a 1970, and I've got an Ultima GTR. all that's just my thing. And in college I had a Triumph. Yeah, I like them. I don't know why that is. I like the lightweight. They're kind of lightly built. I kind of think it's cool. But anyways,
I'll tell you, I had that Lola around. Would it have been around that time? But a slot car.
Oh yeah. I have a 70 Mark IIIB with a 427 Chevy. It's an internal combustion engine car, and it's just it's unbelievably fast. I don't even like driving it. It's just frighteningly fast. But what's amazing about it is how sedate and conventional the handling is. It doesn't handle like a race car. It handles like a street car. It feels like really easy to drive.
Oh, right. But wow, I'd have thought it would be terrifyingly difficult. Right, that's interesting.
Terrifyingly fast. It's scary.
Well, I'm sure. Yeah.
But no, it's very tame, the handling on it. And this is one of Eric Broadley's the guy that is the designer. This is one of the things that people noted about the car, how safe and secure you feel. Even though you're going 180 miles an hour, you don't feel like you're scared. So, anyways, back to our conversation. Sorry, I diverged there.
But I mean, so why do you think that, I'll just quickly do my take on, for instance, battery, the way batteries are advanced. So I have a a 2010 Nissan Leaf. So one of the first Nissan Leafs built in Japan. It was brought over here. It was a press car, and I had it for a few months, and then I bought it. I said I want to keep it, so that I bought it in 2011. Still got it. It's just had a new battery put in it just recently. We're about to release an episode about the experience of having that changed. But intriguingly, when I got it, it was a 24 kilowatt hour battery pack. That was like state of the art, it was amazing, and it did nearly 90 miles on a charge if you were careful and it was in the summer and you didn't go up a hill. And it's now got a 40 kilowatt hour battery pack that is, from if memory serves, from the people who changed it, about 2.5 kilos heavier, but almost double the energy capacity. So it's a 40 kilowatt hour battery, fits in the same, they literally take one out, shift it away, put the other one in, bolt it in, it's done. It fits. There's no, it's not a bigger battery. It is fractionally heavier. But that is, and that battery was the battery I've had replaced as a second-hand one, and it's about 4 years old. So it's not a brand new one. So in that period of time, the energy density of a battery pack, not the actual individual cells, but the battery pack has increased hugely, and the price has dropped enormously, hasn't it? I mean, that, up until recently, I think the price is now, it's definitely not going to go down for a bit. I think we've reached a point. But, that change, I think, has shifted things enormously. The fact that they are cheaper, smaller, lighter, and more energy dense, it needs to go a lot further. But the fact that has changed, and I think that's my argument I'm always making with people who know nothing about electric vehicles, is a lot of people's assumptions are based around 2012. That's what they think electric cars like. And no, it's changed. It really has moved on since then. That for the same price as that Nissan Leaf when it came out, you can now get a car that does about 150 to 200 miles on a charge. Mm. That's the difference. Much, much bigger battery.
Yeah. You brought up the Leaf. I was one of the earlier people looking at getting a Leaf, but the range wasn't high enough.
Yeah.
But it turns out that when I started looking at how much I actually drove, I drive about 15 miles a day back and forth and once in a while I'm on campus at Berkeley. And so I go, wait a minute, am I blowing smoke? So 4 days or 3 days, whatever, I have to charge the battery every 3 days. Big deal.
Yeah.
Now I'm looking at it, but you should say that the batteries, the energy density of the cells has increased as the pound per kilowatt has also decreased. So they're about half of what they cost 10 years ago. I mean, per kilowatt hour. So this is the thing is the complaint that people hear about the electric vehicles these days. Well, it's so expensive. I can buy an internal combustion car for $20,000 or $25,000, and then I go, well, my favorite car is my Chevy Bolt. I absolutely treasure and love the car. What's great about it? Well, I'll tell you what's not great. It's ugly.
Yeah.
it's an ugly little car, but I don't care. What's great about it is I don't care where I park it. If it gets a dent, big deal.
Yeah.
It's narrow. It parks in very tight spots. It has a great turning radius. The best part is I get about 280 miles of range on it in a full charge. Yeah. And it does have temperature-related things with the battery, as all EVs do, that have not been mastered or conquered yet. But it's a great car. So my answer is sure, they're expensive, but they're not that expensive. I paid $28,000 US for my Chevy Bolt. That's cheap. That's a cheap car.
Yeah.
And originally, what I was going to do, Robert, was going to take it apart. The whole thing, I'd take it apart. And then I started looking online after I bought it. And somebody had already done that. So I'm repeating what the guy did. But turns out that that's my preferred driver.
Right.
No one even looks at it. You just drive it around.
It doesn't shout special electric car, does it?
No, it doesn't. It doesn't shout that at all.
No.
So in the Leaf, and I remember that Mitsubishi had an EV a while back, and I don't know if they're still in production, but so these were the options. And you're right. The spotlight has shined on the EVs to a large degree, and the range thing. Yeah. I mean, how often do you have to drive from San Francisco to Los Angeles? You go, well, you can't go very far in it. And I go, well, how often do you do that? Like once a year? And besides, I fly. I just get on an airplane. It's $50,
Yeah.
Round trip on Southwest. So
Yeah.
I just do that, and then I can figure out when I get on the ground, I can take Uber, and I don't want to spend 6 hours in a car anyways, really
No.
not my favorite thing. So that's the thing is the arguments when they hear the arguments and it kind of gets stuck in their head. But when they really start thinking, like in my example of the Leaf, about how much they're actually driving, it kind of fits pretty well. 90 miles or 100 miles of range. It's a big deal, So,
and it's also that thing. I mean, I think a lot of people in this country would assume that an average American would drive way further than we do, just because we live on a small island. And I've driven a long way in America. It's quite big. I've worked out. Yeah. It's quite a big country where you live, but actually most people don't. Most people do their commute and they go to the shops and they're not driving 800 miles each day. It's very, very unusual to do that. So like on your vacation or something, isn't it? It's that sort of once in a while. But then, so what do you think the next step is? Because there's just been a lot of news very recently from Apple about Apple developing. I mean, that news comes and goes. I would love to have a graph of how, of the news cycle of Apple cars. It goes up to a huge peak and everywhere, like 2016, loads of talk about it, and then it just disappears, goes off the map. Yeah. But it's just come back the last few days. They've hired so many people recently, but they're talking about electric, fully autonomous, no steering wheel, no pedals by 2025. I'm not going to hold my breath. I think maybe a bit longer than that.
I still want to move the steering wheel. I still want to drive a car. The autonomous thing, I'm a late bloomer, so the autonomous thing hasn't really hit me yet. Otherwise, I wouldn't own sports cars. I like the car that handles well and it's fast. I'll say this, and this is an example that when I hear the Apple story, I hear people say, well, they have never built a car.
Yeah.
And that's true. I mean, Tesla definitely had teething pains. There were people that were moving here that I knew from Germany that were working at Volkswagen, other places, who quit working at Tesla because it was such a sweatshop. They said it was so hard. Very tough. It's a startup company. It's not, you're not going to be working for Volkswagen right at 5 o'clock, you go home. It's not like that. And they went through their teething pains, but they finally came around. There's still some problems on the Model X, I would say, with fit and finish. But what have you? I have a Model Y, so I'm pretty good with the fit and finish on that. Here's the example. Now, in World War II, General Motors built cars. That's what they built.
Yeah.
And all of a sudden, we need B-17 bombers. The great big 4-engine bomber. Who else can they find to build that? Well, they went to GM, and GM reconfigured a factory in 6 months and started building bombers. Now, here's my argument for Apple, and the argument I hear is Foxconn does not know how to build cars.
Yeah.
But Foxconn builds a lot of stuff.
Yeah.
And my answer to that is, well, neither did GM know how to build airplanes, but they figured it out in 6 months. This is what these companies do. General Motors is a manufacturer. They have the engineering staff to manufacture things just in time. You get an order if you supply seats for GM in a particular car, they got to be there in 24 hours at the factory door,
right? Or
else you don't do business with them. So they know how to do this. Foxconn may stumble a little bit like Tesla, but they'll figure it out.
Yeah.
Now, will people buy an Apple car? I suppose they will. It's probably would not my first choice.
Yeah.
As a consumer, being that they're so new and out of the box, and it has a lot of things that I'm not familiar with, like completely autonomous driving with no creature controls on it. So, but it is it is not a willowing wish. And if you were to say, what do you want in the future to go to work? Let's say you need to go to work. You live in one village and you need to work in another village. Obviously, what you want is you just hail something that says, come get me, I'm here. And it just shows up there. You don't know where it came from. It may have come from another residence or parks out in the woods somewhere. It shows you up and it takes you there and drops you off like a private driver, and then it drives away. It leaves you there. It drives away.
You don't have to park it. Yeah.
No. Utilization rate for vehicles is about 12%. Yeah. Most of the time they sit out in the sun. They do. They sit. And this way you could spread the utilization out in the vehicle to maybe 40%, something like that. And it makes a lot of sense. You have the community ownership of a vehicle where you own your transportation, like my Bolt example, where it's just transportation to me.
Yeah.
You could have community ownership of it where your costs get lowered. and you have a large user base with lower cost for you.
Yeah.
You got people using it. So this is the thinking, I think, is to eventually that's where they'll head. And maybe this is what Apple is thinking with their car project. And I do know folks, over there, and I can't really talk about it, but
Right.
I think they can pull it off. I just don't know that. Yeah. I think here's the thing. I think people are going to stumble at buying it like the Tesla. They're going to go, well,
yeah,
they don't have enough experience driving cars. And then they start getting reviews. Like, that's pretty good. Then their neighbor shows up with one. And another neighbor, and they go, well, I'll go test drive it. And they test drive it and they love it.
Yeah.
And if you've been into the Tesla dealership, when I bought mine, you go into the dealership there, it's a very different experience.
Oh, God, yeah.
And you go into it, there's no guy with a checkered coat on, greasy hair. It's not like that. There's some hipster in there trying to.
Yeah.
So it's a different experience. And he kind of figured out that, I guess the Tesla people figured out that they wanted to change the way the vehicle is sold and produced and all these things. They wanted to change it completely to a large degree. I think he succeeded.
Yeah.
So,
I mean, I think the thing is, we've just been in the Netherlands, in the city of Utrecht, where there is a very big car sharing scheme, electric cars, but they're also using vehicle-to-grid charging systems that they've developed in the city. So, I mean, it's extraordinary developments they're doing there. But one of the things that really stuck with me from the guy from the car sharing scheme, he said, we're trying to do what Tesla did. We're not trying to make a car sharing scheme which is, really difficult and it's a pain and you've got to be really committed to do it. He said, we want it to be better than owning a private car. That the experience for each person that uses it is go, oh, well, this is better. I don't want to own a private car. And they have now 90% of their users that live in the city, and these cars are everywhere. They're not rare; they're really common, and they have a dedicated parking space with a charge point that you plug. So they're plugged in, so you don't have to find a place to park them. You drive them back. But what they found is that 90% of the people who have signed up and used this system have sold their private car within about a year of starting it because it's better, and they have Teslas by the dozen, loads of them. And they have Renault Zoes, the Ioniq 5, the new Hyundai, that's a very popular one. So they are really cool cars. They've got different ones for different purposes. People take them away on holiday. They do, they can book them in advance and have them when they need them. And it's all those things you think, well, wait a minute, what about cleaning them? There's people going around who clean the cars all the time. So they're always clean. They're always,
Up pops another venture or business to take care of that problem, right?
Yeah. And the other, I think the initial reason we went was because all these vehicles are, except for Teslas, not Teslas don't do this, but all the others are bi-directional charging. So they are also utilizing them when they're not being driven. They're being useful. They're either charging them or discharging them, and they can make money out of that as a company. They can, feed electricity into the grid from, very soon thousands of electric cars plugged in. So that is an exciting step.
Tesla makes money off their charging stations. They make money on the cars, but they really make great money on their charging stations. Can you believe that?
Wow. But
I mean, because of the credit system here. Yeah.
Right. So, because I'm a bit confused. I'm a bit confused about, I have a Model 3 and at the moment, and I was paying for supercharging, but at the moment I'm not, because I think I can't remember doing it, but I think I opted for my referral codes. I've put that, the potential income from referral codes into charging. So I'm not paying for supercharging at the moment, but I don't quite know why.
Yeah.
I hope I'm not going to get a very big bill soon.
Yeah. There's a system of credits here. They call them carbon credits and so forth. Where if you're a provider of a charging station, you can get credits for doing that. And it's almost like you could say what'll happen is, I know someone who's doing a startup here. I don't understand the business kinematics, if you will, of it exactly.
Right.
But it turns out that it's almost better to give the electricity away for free because the credits are so profitable.
Wow.
And Musk and Tesla's opening up their charging stations to other EVs now because they found out it's a big source of revenue for them.
Right.
Their supercharger. Wow. There are other charging stations, so they're level 2 stuff.
Yeah.
And one of the professors in class, we had a discussion, just to segue a tiny bit here, about what the infrastructure looks like for charging supercharging stations. And it turns out that in California, at least, only I think it was 4% of the folks who were using. If 4% of the people who owned electric vehicles, and let's assume that most people in California were using the supercharging stations, would use up all the grid capacity. So
Right.
it's not a small amount of electricity.
No.
It's so I don't think that they have figured out. The California won't. I think we'll probably figure that out in 25 or so years. But
Right.
that whole issue of how to provide the electrons and how to get the electrons shipped.
Yeah.
And the answer may be similar to what your U-Track model is where you're allowed to give back,
Yes.
localized, and instead of really being on the grid, it's just a local thing that goes from house to house or something like that.
Yeah.
You can sell your electrons to your neighbors at a premium because they don't have enough, whatever, just
Yeah.
like you would bucket brigade those things around. And that's a really good idea. I haven't thought about the business part of it very well, but
Yeah.
I know some people that are trying to do that. So
Yeah, no, I
working on
think it's going
charging
to
stuff,
develop over
infrastructure.
the next few years. But then the other thing, I suppose, because the thing that I know you've been talking about is the kind of next generation battery. So when someone says, because I'd love you to explain this to me because I don't quite get it, but if someone said solid state battery, I mean, I know Toyota are saying they're working on solid state. A lot of car companies are talking big time about solid state batteries. But are solid state batteries still essentially lithium ion batteries, or are they a completely different chemistry?
Well, let's talk a little bit about how a lithium ion battery, or what's in a lithium ion battery. There's this thing called a cathode and a thing called an anode, which are the little plus and minus marks on the battery. Essentially, that's what they are.
Yeah.
And then there's lithium wrapped around a spongy thing, and then a liquid in there. Well, this liquid is an electrolyte, and it allows the electrons to move around between the cathode and anode through this little membrane. And when you speak of a solid state battery, you're speaking of a battery which does not have a liquid electrolyte in it. And these electrolytes, they can, it's a petrochemical. It can burn
Yeah.
very easily. It's like an oily stuff and it catches fire. So it's kind of nasty stuff. This is what they're talking about when they're talking about a solid state battery in general. Now, the best part about a solid state battery, if you can get rid of this typical cathode and anode materials in a solid state battery and use a lithium, solid lithium, it would improve the efficiency significantly. So, the problem with a standard like an 18650 cell that you find in some EVs, Tesla uses something different, but it's a cylindrical looking battery thing. The problem with those is they is how to get rid of them when they're worn out. And it's
Right.
essentially what do you do with, how do you recycle them, what to do with them. And the primary problem is it's messy, and there's the liquid electrolyte that's inside of it is it's a kind of toxic stuff. So we haven't solved the whole recycling thing yet. But if you had a solid state battery, potentially the lifespan it could be very long.
Right.
Standard lithium ion cells are prone to this thing called dendrites, which are replating internally in the battery, which can puncture the membrane and cause the cell to fail. And potentially a solid state battery would not have these kinds of issues. It still does it's kind of the same thing, but it doesn't really have it as severely. And also a solid state battery would allow much higher current draw out of it. In other words, you could pull more joules of energy out of it very quickly because
Right.
the cell protects itself from excess, like you're taking too much sugar cubes out of it too fast.
Yeah.
You're taking the sugar cubes out too fast. The cell protects itself against that, can protect itself against that. And it's a physical chemical limitation inside the cell. A solid state battery can potentially is not limited in that way. It has fewer limitations, and it's higher, they call it higher current output, higher kilowatt output.
Right.
So these are what people are shooting for when you're talking about solid state batteries. There's a company, Solid Power. There's one of them that comes to mind. There's a couple sort of companies that are working on this that are well funded. A lot of emphasis on this. Can you imagine if you could use the same amount of lithium and reduce the cell size by half for the same equivalent kilowatt hours. This
Right.
is what you want to try to
Wow.
do.
Yeah.
As a matter of fact, the cells could be the size of a small suitcase, and that's your entire battery in the
Right.
car. So this is
Yeah.
what we want. This is what the technology wants. Can you imagine the value of a company like that? How valuable it would be if you
It'd
could
be
do that, pull that off?
unimaginable, wouldn't
Yeah.
it be? Huge. Yeah.
Yeah, it would be there would be billionaires walking around.
Yeah.
So, there are a lot of them around here. So,
Yes,
but there will be
you've
more
got
of
a
them.
few right there. Yeah.
Yeah,
But I mean, I'm assuming as well that if you can discharge a battery at a higher number of sugar cubes or joules at any one moment, can you charge it equally fast? Because in some ways, that would be a really key thing. If you can charge a battery faster, that would be a very attractive proposition to put to people. You can charge this car in 5 minutes or something.
With a solid state battery, you could charge it the thing is the battery is still going to get hot.
Right.
You still have what they call a forward resistance on it. It has it's modeled like this thing called a resistor. So it has a forward resistance on it that still has these problems, but it would be less, and so you'd be able to charge it faster. But you're still not going to be able to put 1,000 amps into it, into an 18650 form factor cell. It's not going to happen like that. But you'd have a higher capacity and a higher current output, higher sugar cube rate coming out of it. So, yeah, it's probable. And anyone who's doing research, and I know people that are working on this, anyone does research on this right now, is in breaking new ground in a lot of ways. So there's other options of battery chemical chemistry, lithium oxygen battery, lithium sulfur based battery cells that have high energy density. There's a lot of research being done there. They do. A lot of them do use a conventional liquid electrolyte, but they are increasing the energy density, and the sugar cube rate is higher.
Right.
So this is the thing where people are working on right now. So,
and I mean, and would you say that the lifespan of a solid state battery is likely to be longer then than the ones we're using at the moment?
Yeah, well, on a conventional battery, like when you buy a AA battery, you go to the store and there's it says Panasonic or whatever, and you put those in. It's an irreversible chemical reaction. Once the chemical reaction has completed,
it's finished.
It's finished. Yeah. Well, that's an extreme example of single-use cell that has one cycle. Right. There are others that have more discharge and charge cycles. Lead acid batteries have limitations. The lead acid battery, like the battery that's in your car, they have to be kept replenished with fresh electrons all the time, or else they self-wear out. Right. In other words, they'll wear out just sitting there.
Right.
So lithium-ion batteries do not have this problem. They don't have a self-discharge problem. If they're charged, they stay charged for 20 years.
Right.
They can't. Yeah, unless they get oxidized or something and fall apart, but they do. So they don't have, first of all, they don't have a self-discharge, and they stay charged for forever. They stay charged. There's no self-discharge current or anything like that. They do have a certain amount of life, and this is what I was explaining a little bit earlier about the sort of this growth of these things called dendrites inside the battery, which puncture the anode and cathode, short out the anode and cathode. So this is the thing you want to try to fix. And the solid state batteries, to a degree, don't really have this problem. Right. And if you can fix that problem, the battery will last for 40 years. Yeah. So you never need to replace the batteries in your Leaf. No. It's just always there, and it just never loses its capacity.
Yeah.
But this is the problem: this was one everyone is working on, and there's big companies working on it. Samsung is a big lithium-ion battery manufacturer. For sure, they have a program in place, as does Sony. But you know what's interesting is sometimes a small company that's agile, without overhead management and a lot of politics, can get stuff done a lot faster.
Yeah.
You cut out. It's like the NASA, the space program in the 60s at NASA. You know how they got that done? NASA realized they couldn't do it with the people with the structure, the internal human structure that they had, the humanity. Right. They had to get rid of all that stuff, the politics and the meetings and all that stuff, and they just chopped it out. They cut the top of it off, and all that's left was like a row of engineers at the bottom.
Right.
Great. And that's how they got that done.
Yeah.
They would, in order for them, Sony and a Samsung to do that, they would have to change their structure. A
Yeah.
small startup company like us at Oculus, we didn't have structure. There was no
Right.
structure there. At first we didn't. When then we started getting structure, and that's, but we didn't have that, and we just killed it. And we're all working on the same thing, much like the NASA thing.
Yeah.
Great subject for a book, by the way. But
oh yeah,
and with a small company, I'm saying sometimes a big company, that's your inhibitor. You may have endless resources, but I see this at big companies where there's like one person trying to angle off the other person, and even though they're working at the same place, trying to make the other guy look bad, so his stuff looks better.
Which is just so crazy, isn't it? But I know exactly what you mean. I've witnessed that.
Yeah, that's what they do. That's what people. That just comes with two legs. If you have two legs, that's part of it. So
that, I mean, would you say, generally speaking, because we do need to wind up now, but generally speaking, I think I sense this from what you've been saying, that you're optimistic about the future of electric ground transport at the very least.
I would say I'm optimistic about it. I think in our case here, I'll just conclude with this statement. Then in our country, in the United States, the electricity is primarily provided by burning natural gas, combusting gas, and then putting it in a generator that generates electricity. It's basically just an induction motor. So they turn an induction motor, generates electricity out like a generator. Those run at the best case 60% efficiency, 60%. Right. So you can't claim that your EV is 94% efficient like Elon Musk does. Because first of all, it's impossible. We measured them. They're not 94% efficient. They're like 80. At the best case is 80. So if you take 80% efficient and then you got 60% for burning fossil fuels, natural gas, you're looking at a 50% net efficiency, which is still better than an internal combustion engine. My point is that we need to produce electricity cheaply with low impact. And how do you do that? Well, nuclear energy. I said at my talk at the Detroit Motor Show that's where we're going to end up, right back where we were in like 1950s. We're going to have to do that whole thing over again. And that will provide unlimited power that we need. If your concern is about global warming and carbon emission, which is a real problem. I'm not going to. In class, we went to an exercise to make the students compute how much carbon a car emits with a liter of fuel. It's substantial.
Yes.
It's not. It's a lot.
Yeah.
So anyhow, if we can bring back cheap, affordable power and upgrade the grid, and most places are going to need this, then we will be on a path to having carbon neutrality if that's your goal. And my other closing statement is, Robert, I remember in the 70s in Los Angeles, it was so smoggy there, you could not see across the basin.
Yeah.
Could not. Now you can.
Yeah.
And why is that? Well, because of regulation. And people complain about regulation. And it's got a downside. It does. It just does. And a lot of politics and weird stuff gets thrown in there. But overall, it's good for humanity. Without that regulation, it'd be still smoky there.
Yeah.
And now it's clear. And it's primarily automobies. Let's face it, the cars.
Oh, yeah. In Los Angeles in particular,
yeah. So I think regulation has good and bad.
Yeah.
The bad part is it doesn't always work the way we think it's going to work, and a lot of weird stuff goes on. The good part is it sometimes fixes things.
Yeah.
So we need more regulation and policy in regards to electric vehicles to make it happen.
Yeah.
I don't think big trucks are going to. I don't see the point in putting big electric, 18-wheelers. I guess I just don't see it, but maybe I'm wrong there. And electric airplanes, I don't think that's going to happen.
Yeah, I don't know. It's very hard to know. Yeah. I mean, I'm basically emotionally, I'm with you, but we are seeing developments. It's not pure battery, but I mean, there's a company just down the road from me in Bristol that are developing hydrogen fuel cell and battery twin engine 20-seat electric passenger planes, and I mean they're flying stuff around,
Oh wow!
And I mean, I actually do think it's 25 years out. I don't think it's impossible for short haul flights, not for transatlantic flights. Definitely, I can't imagine that. But I think possibly just within my lifetime, I'm hoping I live long enough to see, commercial electric flight. Would be. I
hope so
never
too.
have dreamt of thinking of it 10 years ago. It's just ridiculous, but.
Yeah, I hope so too. And
they're
also,
very confident. The companies behind it are very. Airbus Industry. So there's Rolls-Royce and Airbus Industries are very gung ho about electric flight.
That's
so
great.
that's kind of what they do. So maybe I don't know.
Maybe they know what they're talking about. Then,
I think they might do.
So,
but Jackie, it's been really, it's so fast. I wish we could just do, 10 hours, but I think, I'm trying to keep it under an hour, and you've been really patient and very good to do that. And it's really fascinating. And I can't wait to catch up. So we're doing, hopefully you can come along in some way. We're doing a live show in San Diego, Fully Charged Show Live, USA in September of next year. So just a little bit under, is it November? It's late next year. I'll let you know.
Is it LA Auto Show? Or is it?
No, it's our own show. So we did one in Austin just before the lockdown in 2020 when it was a great success. So and we do them here, and we do them in Europe as well. So we've got one in Amsterdam coming up in March, and then another one in the UK in May. At the beginning of May. So they are amazing events because it's not just cars. I mean, we really work on like batteries for your house, solar panels, water heaters, all kinds of new technology in the home and on the road. Electric bikes. There are some electric trucks and delivery vans knocking around, but so I mean, I would love you to come along and join in with that. But we'll be in touch in the future.
Thank you, Robert Llewellyn. I appreciate your time you spent with me, allowed me to speak. If I'm ever in the UK, which used to be frequent, I'll stop by and buy you a nice meal.
Well, that would be. I'm very happy about you. Well, that would be wonderful. I would love to do that. Let's do that one day. We'll manage. All right. Thank you so much, Jack.
All right. Bye-bye.
Well, I really hope you enjoyed that. It was a real pleasure to talk to Jack. I hope we can get him on the show again. He wants to, of course, this is the typical thing. Once we finished recording, he said, I really wanted to talk about electric motors and the difference between permanent magnet and, and I went, oh, damn, I wanted to talk about that too. So we're going to get him back on. So we can really understand, because there's some really incredibly, vitally important technology being developed, and the differences in the discussions around what are the better electric motor solutions, because it does make a difference. If you've got a really good electric motor, it can last a huge amount of time and use less energy to do the same job. Anyway, I won't waffle on anymore. That's long enough. Please do subscribe to the Fully Charged Plus podcast. It's easy. It costs you nothing. It's easy. If you subscribe on your podcast app, or on YouTube if you're watching us on YouTube, and there we go. There are going to be some links to what Jack is doing in the show notes for this episode. But as always, if you have been, I'm going to thank you for listening.